I'm going to start this lesson with listing our prime numbers. Prime numbers. Prime numbers are numbers that can only be divided by 1 and themselves. For example, 2 can only be divided by 1 and 2. The next prime number is 3. It can only be divided by 1 and 3. 1 is not a prime number because it only got one factor. It can be divided by 1, but it must have 2 factors, 1 and itself. There is an argument amongst mathematicians whether 1 should be included as a prime number or not, but at the moment 1 is not considered as prime number. The next prime number, of course, is not 4. 4 is not a prime number because 4 can be divided by 1, can be divided by 2, and can be divided by 4. That is not a prime number because it's got 3 factors. So numbers which are prime numbers must have only 2 factors. One of the factors must be 1, and the other factor must be the number itself. So the next one is 5. Because except 1 and 5, there are no numbers that would fit in 5. So 5 can be divided by 1 and itself. Next one, 7. 1 and 7. 9 is not a prime number because 1, 3, and 9 goes in it. So that is not a prime number. 10 isn't actually any even number except 2 cannot be a prime number. For example, 10 is not a prime number because it's even. 1 goes in it, 2 goes in it, 5 goes in it, 10 goes in it. It's got 4 factors. Even if 5 didn't go in it, 2 would go in it because it's even. And except 1 and 10, we have another factor which is 2. So 10 is not a prime number. The next one is 11. 1 and 11. Next one is 13. 1 and 13. 15 is not a prime number because 1, 3, 5, 15 goes in it. Next one is 17. 19. 1 and 19. 20 is not because it's even. 21 isn't because 21, 3 and 7 beside 1 and 21 goes in it. 23 is a prime number. 1 and 23. There's no other prime number until you reach 29. 1 and 29, and the list goes on forever. Now, we need to know the initial prime numbers very well. Later on, I will make a video of the sieve of Eratosthenes, where you can find the prime numbers between 1 to 100 using his method called the sieve of Eratosthenes. Now, the reason I have started this lesson with prime numbers because I want you to decompose any number in its prime factors. For example, 24. It's called prime factor decomposition. We use branches. We write 24 as multiplication of any 2 numbers you like. Could be 2 and 12, could be 3 and 6, could be 4 and 6, so 3 and 8, 4 and 6, 2 and 12, 1 and 24. But I'm trying to extract as many prime numbers out of it. So say you did 4 and 6. None of these are prime numbers. So then we have to split 4 in 2. 2 times 2. Now 2 is a prime number, so I circle it. And 6, also a prime number. It can be written as a prime number, 2 and 3. So 24 can be written as 2 times 2 times 2 times 3. And you can see these numbers are all prime numbers. Check. 2 times 2, 4, 4 times 2, 8, 8 times 3, 24. Now, if you didn't start with 4 and 6, you could have started, say, with 3 and 8. But 3 is a prime number. And 8 can be written as 2 and 4. And 2 is a prime number. And then 4 can be written as 2 and 2. They're both prime numbers. So we have 2 times 2 times 2 times 3, which is 2 times 2 times 2 times 3, same. Just for one more try on 24, we could write 2 and 12, but 2 is a prime number. 12, 2 and 6, 2 is a prime number, 6 isn't. I can write it as 2 times 3. And look again, 2 times 2 times 2 times 3, 2 times 2 times 2 times 3. Okay, so it doesn't matter which two numbers you write 24 as 4 and 6, or 3 and 8, or 2 and 12. At the end, they split into same prime numbers. Let's do more prime factor decomposition. Okay, let's try with say 50. 50 can be written as any two numbers, say 5 and 10, or 2 and 25. Which of is prime number? 5. So a circle. But 10 can be written as 2 times 5. Both 2 and 5 are prime numbers. So 50 can be written as 2. Write them in an order. 2 and then 5 times 5. And check. 2 times 5, 10. 10 times 5, 50. Let's do 48. Any two numbers. 6 times 8, or 2 times 24, or 12 times 4. So let's do 6 times 8. It makes no difference as long as they multiply to give you 48. 6 and 8, none of them are prime numbers. 6 can be written as 2 times 3 because they're both prime numbers. I'll put the circle around. 8, 2 and 4. 4 is not a prime number. I write it as 2 times 2. Okay, so 48 can be written as 1, 2, 3, 4. 4 2's times together times 3. 1, 2, 3, 4 2's. 1, 2, 3, 4 2's times 1, 3. Check. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 3 is 48. Let's do 64. Any two numbers. So 2 and 32. 32 can be written as 2 and 16. 16 can be written as 2 and 8. 8 can be written as 2 and 4. And 4 can be written as 2 times 2. So 64 is 2 times 2 times 2 times 2 times 2 times 2. 6 2's times together. Now, why do we need to do the prime factor decomposition? Because this is the method we use to find the HCF and LCM of two numbers. In the next lesson, I'm going to show you how HCF and LCM of two or more than two numbers is obtained. Just to specify what H represents, H means highest, C means common, and F means factor. And LCM, L represents as lowest, C for common, and M is multiple. So there are two different things: highest common factor or lowest common multiple. I will show you how to obtain them and what is the use of them. So I hope you've enjoyed this short lesson. See you next lesson. Bye bye.